Okay, now we move into a new chapter on bonding. So this is chapter 12. Bonds hold groups of atoms together, but they do it in different ways. Ionic bonds actually steal electrons. Anions steal electrons from the cations, so that we've got a cation that's missing an electron, it becomes positive. An anion has gained an electron, so it becomes negative. We all know that opposite charges attract, so they pull each other together. Now, some anions aren't quite so strong, and they can't completely pull the electron away from another element. But they have to share the electron then. But a polar covalent bond has sharing, but it's an unequal sharing. However, in cases where you have two things that are bonded together that are the same, like hydrogen gas or oxygen gas or nitrogen gas, they have the same pull on the electron, so therefore they share it equally. And that becomes what we call a nonpolar covalent bond. So we have ionic, polar covalent, and nonpolar covalent. Electrons stolen, electrons unfairly shared, and electrons equally shared. So I've got a little table here that sort of lays out all these differences that happen because of the way these guys are shared. An ionic bond occurs between a metal and a nonmetal. A polar covalent bond occurs between two nonmetals. And nonpolar covalent usually happens between the two same nonmetals, like I sort of pointed out up here. The reason that we have this stealing going on with ionic bonds is that the electronegativity difference is very large, and so it takes the electron completely away and never shares. Polar covalent bonds have much smaller differences in electronegativity. Nonpolar covalent bonds have tiny differences in electronegativity. Now, what we can say about these bonds is that ionic bonds are very strong, because this is a very strong attraction. Polar covalent, weak attraction. Nonpolar covalent, just about as weak. I wouldn't say weaker. Because these bonds are very tight, what they cause is strong intermolecular forces, so that melting and boiling point of ionic compounds is very high. For polar covalent compounds, it's kind of in the middle, whereas nonpolar covalent are very low. Matter of fact, they boil at below room temperature, as evidenced by these guys here. They're all gases at room temperature, and they have to get very cold to form a liquid, and certainly almost near absolute zero to form a solid. So we'll talk more about dipoles in a little bit, and go into more detail on how different bonds give compounds different properties.